If you've been following AI at all, you know that things are moving at an absolutely dizzying pace. I mean, new models, new breakthroughs, they're popping up practically every single week. It's exciting for sure, but it can also feel kind of overwhelming, right? And it makes you wonder, is there a grand strategy behind all this? Is there a master plan for where this is all actually going? Well, today, we're going to dive deep inside the thinking at Google DeepMind to try and figure that out.
And yeah, this quote from DeepMind's CEO, Demis Hassabis, just says it all. The speed is so intense that even the folks building this stuff can barely keep up with their own work. So, how do you possibly navigate that kind of momentum? What's the roadmap?
So, to make sense of DeepMind's big plan, here's how we're going to break it down. First, we'll look at the core problem they're trying to solve. Then we'll explore the 3 key strategies or pillars they're using to tackle it. And finally, we'll see where this is all leading, a vision that they call the Omni model.
Okay, first things first, we have to understand the central challenge here. And it's this really fascinating paradox that kind of defines AI as it exists today. On one hand, these systems are capable of just unbelievable brilliance. But on the other, they are filled with these shocking, almost silly flaws.
I mean, get a load of this contrast. On one side, you have an AI that can win a gold medal at the International Mathematical Olympiad, solving a problem that stumps the absolute brightest human minds on the planet. And then, on the other side, that same type of model can make a basic high school math error or completely forget the rules of chess mid-game. It's like having a genius who, well, can't tie their own shoes. It's just bizarre.
And this brings us to the key term that Demis Hassabis uses, jagged intelligence. See, the intelligence isn't smooth or consistent, it's jagged, with these incredible peaks of genius and these baffling valleys of incompetence. So overcoming that jaggedness, smoothing it out, and creating a more reliable, well-rounded intelligence, that's the fundamental goal for DeepMind.
So how do you even begin to smooth out that jagged intelligence? Well, the first big strategy is to teach the AI to actually think, to reason and to plan, instead of just blurting out the very first answer that comes to mind.
The process, which they call deep think, works a little bit like how we might solve a really tough problem. First, the AI doesn't just produce one answer. It generates a bunch of possible paths, or thoughts, all at the same time. Then, and this is the key, another part of the system acts like an internal critic. It analyzes each of those paths for its logic, its quality. After weighing the options, it picks the single best, most coherent line of thought. And only then does it give you the final, polished output. It's basically a system for thinking before you speak.
And the reason this is so important is that this kind of deep reasoning is what's absolutely necessary for tackling the world's hardest problems. We're not just talking about winning math competitions here. This is the key that could unlock major breakthroughs in programming and drug discovery in fundamental science. This is what transforms AI from just a clever text generator into a genuine partner in problem solving.
But here's the thing. Intelligence isn't just about abstract logic and language, right? We live in a physical world. So for an AI to be truly useful, it has to understand that world. And this brings us to the second pillar of their strategy, building an AI that gets physics and objects and space itself.
The core idea here is something called a world model. And this isn't just an AI that can look at a picture and say, that's a ball. No, it's an AI that understands that if you drop that ball, it's going to fall. It gets intuitive physics. It gets object permanence, the idea that things still exist even when you can't see them. This is the missing piece of the puzzle for stuff like advanced robotics.
So how in the world do you prove an AI actually has a world model? Well, you ask it to generate a world for you, and this is where this incredible system called Genie comes in. You can give it a super simple prompt, like a kid's drawing or a photo, and it will generate a completely new playable 2D world. It's interactive, and here's the crucial part. It's consistent. If you walk your little character off screen and then come back, the world is exactly as you left it. That shows it has a real underlying model of how that world works.
The potential here it's just staggering. First, on a really practical level, you can use it to create endless virtual training grounds for other AIs, like robots or self-driving agents. Second, you could create entirely new kinds of entertainment, something that's a blend of a movie and a game, where you're exploring a world that was literally just imagined into existence.
And third, and this is maybe the most profound, it becomes a tool for scientists to ask really deep questions about our own reality and even simulation theory.
And this is where things get truly mind-bending. As Hassabis puts it, you can take a game-playing AI agent and put it inside a world being generated on the fly by Genie. So you literally have one AI playing a game inside the imagination of another AI. It's a completely wild concept, and it's not just a theory. It's happening in their labs right now.
Okay, so we've got an AI that can think and an AI that understands the world. But how do we measure its progress? I mean, how do we actually know if it's getting any better? This brings us to the third pillar, the need for a completely new way to evaluate AI, because the old ways just aren't cutting it anymore.
See, traditional benchmarks, like standardized tests, they're getting saturated. The best models are already acing them, so it's hard to tell if they're genuinely smarter or just really good at taking that one specific test. The game arena is a totally new approach. For one, it scales automatically. As models get better, they play against tougher opponents, so the test is always getting harder. It's also perfectly objective. You either win or you lose, simple as that. No subjective human ratings. And finally, because every single game is unique, there's no way to cheat by leaking the answers ahead of time.
And what this all gets at, really, is that the goal isn't to build an AI that's a grandmaster at chess. The goal is to build one that can learn to play any game you throw at it, thousands of them. This is what forces the models to become true generalists, to develop a flexible, adaptable intelligence instead of just very narrow, specialized skills. Okay, now it's time to bring it all home. We have these three big pillars: deep thinking, world modeling, and a new arena for testing. But these aren't just separate, isolated projects happening in different labs. They are all converging toward a single, unified vision for what AI can become.
Think of it like putting massive puzzle pieces together. You take the language and the reasoning capabilities of a model like Gemini, you combine it with the world generation powers of Genie, and you add in the ability to see and understand video from a model like Veo. Each one of these specialized systems becomes a core component of a much bigger, more powerful whole. And the ultimate goal of all this convergence is what DeepMind calls the Omni model. One single, powerful, integrated system that can basically do it all. It can see and understand the world through any sense: text, images, video, sound, and then it can reason about it deeply and generate entirely new worlds and ideas. This is the destination on their roadmap. This is the whole shebang.
And that really leaves us with a final, fascinating thought to chew on. This whole journey isn't just about building cooler technology. As we create AI that can generate and simulate entire realities from scratch, it kind of forces us to look at our own world through a completely new lens. What does it even mean for an AI to learn physics? And as it builds these incredible digital worlds, what will it ultimately teach us about the nature of our own reality?